In this video, we'll work a Coulomb's law problem involving finding the force on a charge due to two other charges. So I'm asked to find the resultant force, in this case, on charge number 3. So one of the things I'm going to want to do is I'm going to draw a free body diagram of charge 3. So here's my charge. And this charge is going to experience a Coulombic force due to the charge 2. Charge 3 is positive, charge 2 is negative, therefore that force will be attractive, and there will be a force in this direction, which I will call F2. There will also be a force on charge 3 due to charge 1, and it will be along this distance, which is a times the square root of 2. And that force will be repulsive because both are positive charges. So there will be a force like this, F1. And we need a coordinate axis. There's X, there's Y. This angle here, that force is like that. That angle is the same as this angle. This is an isosceles triangle here. So that angle is 45 degrees. So it's just like other problems that we've worked in the past. The only thing now is that we need to use Coulomb's law to find the length of these two forces, and then break the vectors up into their components as we've done in previous problems. So to find F1 is equal to K, magnitude of Q1, magnitude of Q3, because that's the two charges we're talking about, divided by this distance, which I will call R1, squared. So that's 9 times 10 to the 9th Newton meter squared per Coulomb squared. The charge was 5 times 10 to the minus 6 coulombs on Q1, and on Q3 it was the same, so that's squared. Now, this R squared, it is convenient when you're looking for a hypotenuse to realize that the square of the hypotenuse is the sum of the square of the other sides. So that's A squared plus A squared. But we know what that is. That's 0.1 meters squared plus 0.1 meters squared. Now that I have all those numbers, I take my calculator and I sit down and I compute. So 0.1 squared plus 0.1 squared equals, inverse that, times 9 second e to the 9, times 5 second e to the minus 6 squared, and I come with 11.25 newtons. So 11.25 newtons. All right, not looking yet to find the x and y parts, just finding the magnitudes. For F2 we have K, magnitude of Q2, magnitude of Q3 over the distance R2 squared. That's 9 times 10 to the 9th Newton meter squared per Coulomb squared. Q3 was 5 times 10 to the minus 6 coulombs. Q2, I have to go back up here and look. Q2 said 2 microcoulombs. Remember, we do not use the signs. All signs are handled by the free body diagram. Minus 6 coulombs. And then all of that is divided by 0.1 meters squared. So F2 is approximately, we got to punch calculator again, 9 second e to the 9 times 5 second e to the minus 6 times 2 second e to the minus 6 divided by 0.1 squared. I get 9, assuming that I've done that correctly, 9 newtons. Now, let's find the sum of the forces in X. F2 is in the minus x direction, so I have minus 9 newtons in the x. This side of F1 is along the x, and that's going to be the cosine of 45 degrees times F1. So the sum of the forces in x is minus F2 plus F1 cosine of 45 degrees. And if I punch that in my calculator, I get minus 1.845. I'm sorry, minus 1.045. Getting a little bit blind in my age. Alright, sum of the forces in y is simply F1 sine of 45 degrees. And I get 7.7 7.95 newtons. So the answer to the problem, if all they asked me was find the force, they didn't say find the magnitude or anything, said find the resultant force, then the answer to the problem is minus 1.045 newtons I hat plus 7.95 newtons J hat. That's the answer. Now, if they wanted the magnitude, one could simply go over here. There's your 1.045 newtons. And there's your 7.95 newtons. And you could find this length here. And you could find that angle phi with the tangent function. And then you could add to that 180 degrees, and you could find this force in polar form. It just depends on the problem and the way they ask it. All right, that is the end of this example. I'll see you in another video.